Dear learners, I welcome to this MOOC course on cartographic techniques practical. Today we are going to discuss map and mapping process, which will focus on basic mapping techniques, and I am Professor Jaganathan, Professor at Department of Geography at the University of Madras. So, the topic is maps and mapping process. Map is a powerful tool to explain whatever we are doing now. And today we are going to see the following learning objectives. So, number one is identify 4 main cartographic process. So, what are the cartographic process we have? How we are going to process step by step. Number 2, differentiate between 2 primary categories of maps. So, when you do your cartographic process, we have to think what type of maps we have, how we can design using different types of layout and other things. The third one is execute the 8 essential steps mapping workflow. These 8 essential steps are very important steps, and step by step we will discuss later. Finally, we try to understand integration of spatial and attribute measurements. So, when we talk about maps, always we have to talk about spatial and non-spatial. Non-spatial also related to attribute data management. So, there are 4 main cartographic processes are there. How we process the map? So, before talking about mapping process, we have to understand what is really mean by this. If you see this, first one is data collection and selection, and data manipulation and design, then information interpretation, map reading. There are 4 processes we have. First one is data collection and selection. What is mean by that? We try to collect different types of spatial data using satellite images, GPS and other satellite techniques. After capturing the data, we have to select what are the features we are going to select. So, selection of data, selection of any geographic entities depends on the purpose. So, cartographer first will collect the data, then we will select what are the important information we have to select. The second one is data manipulation and design. So, here process and design a map is very important one. So, first one, village land use map. For example, I want to prepare a village land use map. For that, cartographer will collect the data from the field. They will go to field and they will collect data from village administrative officer, then land use map from satellite imagery, then he will select and everything. Then after that, data manipulation and analysis. So, here population density map is a good example for that. When I want to prepare a population density map, I have to collect data about population from census data, then I have to manipulate it. Using different types of formula, I have to prepare a population density map, saying low density, medium density and high density. So, that planner will be able to understand where we have a less density, where we have a high density. The third one is map reading. Normally, student will read the map based on the conventional signs and symbols. Using legend and other things, you will be able to read where we have agricultural land use, where we have a contours, all those things will be read by student or any user based on the conventional signs and symbols. The fourth one is information interpretation. Here user will be able to analyze and extract meaning from the toposit or any thematic mapping. For example, planner wanted to have a flood potential map. So, flood potential map we will prepare. So, rainfall map is a very important map. It will try to explain where you have a high rainfall, where you have a less rainfall. Based on that, planner will be able to manage all those things. When you want to cultivate paddy, it depends on the rainfall. So, 4 processes are very important process in cartographic phenomena. Now, after that, the end product of cartographic process is maps. Then we have to think what are the fundamental elements of maps. So, there are 2 elements, one is location, another one is attributes. So, location means it is about latitude, longitude. If I want to prepare a location map of all universities, then I have to think how I can do it. Using GNSS, I will be able to locate all the point features. I want to prepare a line feature, for example, road map, this is a good example for location. Number 2, attributes. Attributes related to characteristics of a particular location. When I want to locate all the wells of a particular area, that is called locational parameters. I want to talk something about well, that is characteristics. Who is the owner of the well? What are the depth of the well? What are the water potential, whatever the water quality, all those things will be good example for attributes part of the map. So, this is interactive map and you can see here a table, it is like a Excel. Here you have a map and attribute table. Attribute table may be population map. So, I will prepare a population map from census map. I will try to integrate attribute table into map, so that I will be able to get a thematic map like a population density and other things. So, this is a good example for location and this is good example for attributes. In attributes, lot of attributes are available. So, now after location and attribute, we have to think what type of categories we have in map making. Mainly we have two types of maps. One is thematic maps, another one is topographic sheets. Normally topographic sheets are produced by government agencies. In India, Survey of India is a government agency, they produce topographic sheets at different scales, and these type of topographic sheets will give you basic information about terrain, latitude, longitude and all the basic geographic features. The second one is thematic maps, this will show a particular theme. We try to prepare a thematic map. Thematic map be simple thematic map and complex thematic map. Already I told you population density map is a good example for thematic map. Now, we have a different types of steps we have. We normally call it as a essential elements of mapping process. If you read here, essential elements of mapping process, it is a technical process of map making. There are 8 mapping steps are there. Number 1 is establish the purpose, number 2 define the scale, then select the features, choose representation, generalize features, adopt projection, apply referencing, annotate the map. These 8 processes are very important process before making your maps. Let us see first one, the purpose of the map. What is the purpose of map? And if you see here, all maps and spatial data sources are generated with a specific purpose in mind. What is that specific purpose? Purpose may be single and purpose may be multiple. Some maps serve one or more themes, that is called complex thematic maps. If I am going to represent only one theme, that is called simple thematic map. So, what is the purpose, what I am going to do with it? So, for example, I am going to produce a flood hazard map, and for flood hazard map for a particular city, what I have to do? So, I need to select a scale, then I have to see what are the data I need, whether I have to collect data from field or I have to collect data from satellite data. So, depends on the purpose, I have to prepare my map. The second one is we have to understand the map scale. So, maps may be at different scales. Normally, we try to talk always about small scale map, medium scale map, large scale map kind of things. If you see here, we use like this verbal scale, ratio scale and graphical scale. Verbal scale explains in words 1 centimeter equivalent to 1 kilometer, and ratio scale explains 1:50,000 map. That means ratio scale trying to explain 1 centimeter equivalent to 50,000 centimeter on the ground. The third one is graphical scale. Using graphical, we try to prepare a map. Most of the times graphical scale is suitable for preparing any type of map. When you reduce an enlarged map, automatically your graphical scale will be reduced or enlarged. In addition to that, based on the size of the area, we also divide large scale map and small scale maps. What is large scale map and what is meant by small scale map? Let us see here. If you see, small scale maps covers entire world or entire Asia or the whole India. In small scale map, we represent only major features of the earth. We cannot explain or we cannot represent everything. When you come to large scale map, you can represent everything. Good example may be our urban map. Cadastral map is a good example. Maybe 1 centimeter equal to 1000 centimeter. So, these detailed map will give you every information, each and every information, all the location of schools and details, but small scale map will give you basic ideas about the geographic features. The another one is representing features with symbols, representing features with symbols. So, how we are going to select features? And here if you see point symbols, line symbols, area symbols, 3 types of symbols we have. When I am going to prepare road map of a particular district, then I have to select line based features. If I am going to locate all post offices, then point based features will be selected. If it is going to be area, For example, I want to prepare a land use land cover map, or I want to prepare a vegetation cover, then it is a area based. So, it depends on the purpose whether you are going to select a point based or line based or area based, then we will be able to select all those things, important geographic features, and it also depends on the scale of the map. So, if you see these figures and we have points, lines and areas, and we represent tree using a point feature, and telephonic lines is considered as a line feature, then this is a animal range area. When you want to explain the airport, airport is a point feature, then highway is a line feature, then any watershed is a good example for area feature. Streams are line features, and area, if you see chemical spill, if the wide area, that is an area, if it depends on the scale of the map, if I am going to convert into small scale map, area will become a point feature. Then administrative area also good example for area feature. Just now I told you I have to represent all the geographic features depending upon the scale. If it is a large scale mapping, I have to give full details. If it is a small scale, I have to reduce it. Area may become point or point become an area, line may become an area or line may become point, it all depends on the scale of the map. Here generalization plays a great role. If you are not able to use generalization, I cannot represent everything within small area, you will not be able to read. So, we need to have a generalization, different types of elements are there to explain the generalization. If you see here, the one is selection. If you read here, there are lot of geographic entities are there, here selective entities are represented, this is called selection. Another one is simplification, and this river, if you see the river, lot of curves are there. When I am going to reduce it, I try to simplify the coastal line, simplify the river. The third one is aggregation, and this is a detailed map, and if you see you have 5 points, I try to have only one point. I try to aggregate everything in one entity, so that user will be able to read perfectly, he will not have any confusion. The third one is very clear, every time we try to aggregate when we want to reduce the map. Then we have a displacement. What is mean by that? Along the rivers or along the roads, different kind of geographic entities may be there, maybe settlements, maybe some particular industry, maybe school. Purposefully we try to put everything nearby a river or nearby a road, that is called displacement. Another one, collapse, and if you see here, this is an area map and this is actually a river, and this river has a area, and I am trying to reduce it here, and here area will become a line, is called collapse. In A4 size map, when I want to prepare a Tamil Nadu map, Chennai may be point feature. In A4 size, I want to prepare only northern part of Chennai, automatically Chennai point feature will become an area. This is a good example for collapse. Then exaggeration finally, and this is an area feature, and we have a 2 point features, and this is a line feature, and here we have a exaggerated. I try to exaggerate, I want to represent this, readers should read this, so I will try to exaggerate this. So, these are all the very important elements of generalization. When you want to prepare any map, we have to think what scale, whether it is a 1:1,000,000 or 1:10,000, depending upon the scale, I have to use these elements of the generalization, so that you will be able to understand how you can represent all the geographic features. Now, I know how to represent the features, and earth is a 3-dimensional space, how I can transform into 2-dimensional space, it is very difficult. So, transforming 3-dimensional surface onto 2-dimensional space is not an easy job, because I want to represent everything. So, we need to have a map projection. See, this is the map projections, and what is it? You see, projection is a project a sphere onto a flat surface. Simple definition is transformation of 3-dimensional spherical earth onto 2-dimensional space, very simple. When you do it, you will see the scale, and you have to think different types of projection methods, and distortions will be there, lot of other things will be there, and this is a 3-dimensional space, and they have transformed into 2-dimensional space. We all see only on the paper, only 2 dimension. It is very difficult to transform 3D to 2D. So, when I want to do this, we have major types: planar, conical and cylindrical projections. Depending upon the location, whether your country is nearby North Pole or latitudes or equatorial region, we have to choose a projection. Because it is a 3-dimensional space, we transform to 2 dimension, very difficult to conserve or preserve shape, size, distance and direction. I use the term projection. What is meant by projection? I already told you. Now, for that, spatial referencing systems are there. Spatial referencing is nothing but we try to locate each and every geographic entities using geographic coordinates, that is called mathematical location. And what are the types of spatial referencing systems we have? If you see here, the first one is geographic coordinates, number 2 is rectangular coordinates and non-coordinate systems. We can use these 3 coordinate systems to represent the geographic features. First one, geographic coordinate systems. Geographic coordinate systems uses latitude and longitude, and lines of longitude is called as a meridians, lines of latitude is called as a parallels. Network of parallels and meridians are called graticule. This graticule is a good example for georeferencing. Using these georeferencing systems, we locate everything. Now, number 2 is rectangular coordinate systems. I want to project this 3D to 2D. I need to transform lot of things, lot of formula is there. And good example for rectangular coordinate system is UTM, Universal Transverse Mercator Projection. Another one is UPS, Universal Polar Stereographic Projection. For polar regions, Universal Polar Projection is a suitable. Other than that, Universal Transverse Mercator Projection is a suitable projection system. This will transverse Mercator projection and divide the earth into 60 vertical zones that are 6 degrees of longitude wide, avoiding the polar regions above 84 degree north and below 80 degrees south. So, we have a 60 horizontal, 20 vertical zones. Using these things, you will be able to locate your place. So, this is a universal transfer projection, and you can see here. So, from here to here, number 1, 2, 3, you have a 60 zones, and all are the letters 1 to 60. In the vertical, we use English letters, and you can see here C to X, 20 zones we have, and using this you will be able to represent any part of the world. This is non-coordinate system. See, this is not a coordinate system, this is non-coordinate system. You have a different types of system, because geographic coordinate system explain with reference to latitude, longitude. Rectangular coordinate system uses UTM. You have a 60 and 20 zones, and this is not at all related to coordinate system. Non-coordinate system also very useful to locate any part of the area. So, number 1 example is postal code. Different postal codes are there in different countries, and in India this is the postal code, and this 5 represents a region, then 1, 2, 3, 4, it all depends on the location. This is particular state, finally this is a post office. Using the postal code, I will be able to locate a particular house. Non-coordinated system is a perfect system to locate, not scientifically, for administrative purpose. And another one is administrative units. It is a second example for non-coordinate system, and this is we have India, administrative boundary. We have a state boundary, we have a district boundary, we have a sub-district, taluks, village boundaries. Using those administrative units, I will be able to locate where are you coming from. Other than that, we have a political boundary, we have a parliamentary constituency, we have assembly, then local government boundary, we have a municipal corporation, municipality, gram panchayat, all those things. The third one is street address, and if you see here, this street address will give you exact location of your area. So, now we have geographic coordinate system, rectangular coordinate system, non-coordinate system. Using these 3 spatial referencing systems, you will be able to locate or identify a particular geographic entity. Finally, map annotation and labeling. Annotation is nothing but adding labels, Many times we see the Google map, I have a satellite data, I have a photographic data, aerial photographs. These aerial photographs, satellite images are good example for landscape model. Normally imagery does not have any annotation, just you can see the picture. When you see the picture, you will not be able to understand where is your place, you will not be able to identify whatever it is. You can see point feature, line feature, area feature, but you do not know what it is. So, what we have to do in mapping, annotation is a very important element. I have to give name for each and every entity. One point is there, I have to tell whether it is a well or some other things, and another point may be government secretariat. So, I have to see those things. For that, this is very important. And derive from attributes. First one, in most cases labels are derived from the attribute data of the features. So, when I have a name of the places, whatever the population density of each and every place, and I have to write it. Next one is I have to add a context. Labels may be include contextual information when we require. I have to write every point feature, what is the name of the city, whatever the name of the road, particular water body name, all those things are good example for annotation. And we have to write the legends, all conventional sciences symbols, I have to write what is it, it try to explain what exactly a particular geographic entity explains. So, includes keys and legends also part of map annotation labeling. So, labeling is the final one. The real difference between the satellite imagery or aerial photograph and map is annotation. You do not have any annotation in aerial photograph, that will not give you any meaning at all. So, these aerial photographs are again I tell you it is a landscape model and map is a cartographic model. Finally, map production. We are going to produce using these steps, you produce your map, and from data collection to presentation. What we have here is the map production includes both measurements and graphic design, combining technical data collection with cartographic presentation. So, we have two things, number one is spatial measurement, number two is attribute measurement. What is spatial measurement? When I want to prepare a map, I have to use toposite, or I have to use satellite data, or I have to use field survey conducted by our people using GPS. These instruments, these map sources try to explain the location parameters. This is called spatial measurement. We try to measure the location, distance, direction, area, and whatever you want to do. Another one is attribute measurement using questionnaire survey, field data collection and direct measurement. We try to collect the data. What about the questionnaire survey? I have to prepare a questionnaire, then I have to meet people, then I have to ask about whatever I want. Maybe perception about the clean city, I can ask people, then they will tell you everything, and that is called attributes. Water quality, what they feel about water quality of the area, I can collect from them. Then direct measurement, sometime I can have a app, I can collect data about noise and other things. So, these spatial measurements, attributes measurements are very, very important. I think initially we discussed about location and attribute elements, and that will be based on this. The finally, cartographic design, applying design principles to create effective visualization communication through thoughtful graphics and layout. Here your artistic skill plays a great role. When you want to design a map, you have to think what type of color you have to select and what type of pattern you have to do. So, design is very, very important. So, spatial data measurement, attribute data measurement, I prepared all the maps, then using the cartographic design principles, I have to complete the mapping process. Now, in summary, the mapping process involves data collection, data selection, manipulation, map analysis, map reading and map interpretation. And we have 8 steps, using those 8 steps we try to complete the mapping process. And here each step ensures accuracy, clarity and effective communication, because map is a communication tool. The aim of the map is to communicate whatever I want to tell. So, by integrating science, technology and design, maps support informed decision making in planning and development. So, we have discussed two things, one is cartographic process, another one is mapping process. Cartographic process is a general process, mapping process is a technical process. Using 8 technical steps, you can prepare a beautiful accurate map, whether it is a manual map or a digital map. Thank you very much.